It's like gain strength faster instead of less. Any reason why? You give me a reason, I give you a fact. Why? Okay, supplementary cement, which I will talk about, but I just give you an idea. OPC, you react with water, creates the CH shell. Supplementary cement, it reacts secondaries with the byproduct of OPC, create more CH shell. So generally, it actually takes longer time to react, to be fully aggregated. Yeah, so it depends on your type of cement that you use as well. Generally, but of course, for certain cases, generally. But of course, depends on how fine the property of GBS or fly ash depends. It also depends. Sometimes it might react faster, but generally, you need more time. And also curing. Curing, you guys think curing is important? So general, what do you think curing? How long do you need to cure for concrete?
Egg yolk.
Egg yolk. What's the egg yolk?
No, egg yolk.
No. Water cure. It means proper curing. Yes, generally you need 28 days, but right now I think the practice, they don't really practice 28 days. Okay, so this one is the chart. But it's arguable, because this one, concrete, the strength when you egg cure versus when you cure at 7 days, the strength development might be as high as 30% or 40%. When you fully cured, the strength development, the gap might be even bigger. Yeah? But for mass concreting, it's arguable because they mentioned, because underneath is still fully cured, but generally, curing is important on any construction. It's concrete placement. So without curings, your water evaporates too fast.
If you put because I saw a certain plant that you put inside the lab. So in the lab, you don't know air condition. So air condition, moisture, then there's
Yeah.
all this definitely certain, I believe there's certain affecting the strength level.
Yeah, strength is actually developments is also, this one is just purely on curings. We haven't touched on the weatherings. Yeah, so if let's say you have different weather exposure, you are exposing for like big wind or different temperature changes, concrete might be even different. Yeah. So this one I just mentioned purely just on curing. The impact of curing. But of course you put it aside, why sometimes you see a lot of cracks, even though, but there's a lot of different factors. Yeah. So this one is purely just on curing. One cure, one without cure, same condition. The impact. What's the impact? Like,
One is site condition, maybe you say open air.
the open air.
Yeah.
When you have open air, especially on concrete towers, you see a lot of cracks.
The water vibration in the concrete will be faster.
Yeah.
That's why we say the hydration we need water for,
What about
for the
like
latter.
some slack concreting they put, I think wet uni? Is that considered as moist curing?
Why they put that?
Provide the
Why?
provide the loss of water.
Yes.
That is considered as moist curing or air curing?
Moist.
Because of the wet.
Yes.
So the ultimate objective of your curing is not to let the water evaporate out.
Yes.
You want to make sure your concrete or your cement still keep on hydrating until it achieves certain strengths. Yeah, but with the development of OPC, maybe I would say 100 years ago and now, right now everything we want fast. Nak cepat, tak boleh tunggu. Next day I want to open my homework. Next day, not 7 days. Next day. So I think there's a lot of developments on both, even for cement itself. Yeah, it changes quite drastically. Yeah.
Earlier on our IGD 1000, we built inside
Yeah.
the whole one was immersed inside the water. Yeah, so that time because of course the production was less, become less already. So the R itself now time to show. Pretty sure.
So a couple of months ago, I think about 2-3 months ago, so we did it for the 28 days after removing, after steam curing, then we take out and put it inside the water cure for until 28 days now, but
Yeah.
not significant like that.
Yeah.
Then about different about 1 MPa.
Because after you steam, actually your porosity increase.
Yeah.
In microstructure porosity increase, the strength increment is less.
Less.
For comparison, steam curing compared to water cure,
Mm.
actually the minimum requirement is 90% of your. Let's say you are 50, target 50, you only get 90 times 50, 45.
Okay.
That's why if you want to use steam curing, the best you need to top up your additional strength. So that after you steam, you pass your 50. That's the drawback because after you steam, the porosity increase. Okay, compared to UHPC, the one Dura is doing is different story. Because they cure after the steam after the next day, which already a 10 required strength. Then that one is under Japanese standard, if not mistaken, is 90 degree for 48 hours.
90 degrees.
It's different category. So, but they wait until they gain certain strength. At least one day for UHPC, our experience is 70 MPa. Already acquired 70, then you send it to the high temperature curing back to me. That's different story, different methods.
They do that for the durability of the concrete.
They want to boost up to 100 MD because for common material in Malaysia, if you don't do steam curing, the highest you can go is 150 above.
Okay.
Around 150 to 150.
Okay, second is your air content. So air content higher, the strength? Lower by how many percent? Generally, guideline. So, in general, 1% of air is your strength by? The low is also answered, but you already got your hit. So, yeah. So, generally 1% of air, you actually need 5% strength. 5% is 5% of the strength.
But is it true that to the certain ambition they actually want to create this air increment for pumpability?
Air entrainment for pumpability is arguable. So for if let's say you ask me, I won't do it. I won't do it unless you want to really entrain air for freeze and thaw. That means you are experiencing these freeze and thaw gatherings, then you only entrain the air. But generally, your concrete will have air. Maybe for your case, maybe less than 2%, less than 1%. Depends on your specifications. Yeah, or 3%. Depends on your application. But generally, we do not want your A to be low as high as 5 or 6. Yeah. So we want a right. So second, retarders and accelerators. So you add retarders to
Problems, your setting time.
problem setting times. Makes your strength developer also longer lah. So accelerator is vice versa. Yeah. So you are adding accelerator to increase the early strength. Yeah. Increase the early strength. So that's actually way to be. Yeah. So next is your temperature. So the higher temperature, faster the setting time also lead to your faster the strength gain. Yes, correct. If you want. Right. So I think ultimately it's right. So I think a lot of times, sometimes specifically, first is the grinding process. So they have to grind the limestone into a smaller pieces, primarily secondaries. Any reason why they want to grind? Surface area is one thing, but ultimately, yeah, save cost. Because you have to go through the burning process. So you want to burn the material into a smaller pieces to ease up the burning process. So you actually, after that, you go through a grinding mill. They will preheat the limestone cement. Any reason why they want to preheat? Save cost is one thing, but why they want to preheat the limestone? Yes, remove moisture. Basic reason. Because you have to go through a burning process which require a lot of energy. So this is process clean, require is the most energy consumed. So that's why they want to remove the moisture as much as possible before they go into the clinker. Yeah. So under this process, it will actually burn down the limestone powder to a smaller pieces. So under this temperature, the temperature can go as high as 1500 Celsius. Yeah, it's very hot. So this is the process that contributes to CO2. So after that, you will actually go down to a point, cooler. So you actually bring down the temperature to 100 degrees. So most of the plants, they will actually reuse back the water. First from 1005, reduce down to hundreds. That's actually, the energy is still the same. So actually generally they reuse back the recycled concrete for preheating purpose. Yeah. So after that, they will actually go through this grinding process. You add the gypsum, then here's the OPC. Yeah, that's the general process of making OPC. Okay. So in OPC, there's 4 main components. If let's say we study top of OPC, any clues? What's the 4 main components? Anyone? All right. So the first one is tricalcium silicates. So I think this is a few components that we need to know, because sometimes these chemistry properties might impact our concrete as well. So tricalcium silicate is the one that contributes the most on the early tracks, which it also generates certain heat on your early stage. Yeah, this is. So dicalcium silicates for your later track. Tricalcium aluminates is the one sometimes you need to be careful about, because it will impact a certain thing. So sometimes, for example, I run the trial from same brand, for example. Somehow, certain batch said not only apart, no matter how many water.
It's okay.
Sorry. It's my weight issue.
No.
Trying to sleep now.
No, it's not the issue.
Okay, but yeah. So sometimes, I'm not sure you guys have an experience. Certain batch cement, no matter how many water, how many MHs you put in, the initial slump or you can't achieve. Yeah. So this one is called fast settling. Sometimes, primarily not because maybe some cases maybe it's not okay, but this one is also
Another left off, another C4F.
yeah. But another one is tricalcium aluminate. Right. So this one it actually contribute a little bit of colors. So sometimes if let's say your customer comes, hey, how come color also different? One is more gray, one is more darker. So this one is one of the components that mainly contribute on the colors. Yeah. So but it's natural. Because you can't control. If let's say your color complain, hey, why this one is darker color, this one is lighter. Because we are dealing with nature. Because you are dealing with materials billions years ago. You also answer to the question. Because you can't control, my bone maybe is whiter than you, or your bone is whiter than you, we can't control, right? Yeah.
C4AF, higher content generally darker grayish colors.
But which generally is hard to control. It's hard to control. If let's say like you can answer it's really cement. You ask him, okay, I want this grayish color, this color.
It's very hard to control because of the clinker source. Because different part of the quarry, the clinker is different in iron content. They contribute to the cement's color.
Yeah.
But C4F higher will slightly improve strength or the other way around.
It doesn't really impact that much.
It's slightly on the early strength.
It's only very slight, very minor.
Not the major.
No, because sometimes you send house darker gray or then reach the side, then you will say, oh, your house not cured.
Then this one you have to ask the cement supplier, put it more, make it darker. But generally it won't.
This is more the clinker, mineral composition, chemical composition.
So I think right now,
They cannot be sustained forever, that kind of thing. Time to time they will change.
I think last time MRP when they got this issue, really hard to find the monster connection.
That's why certain precursor they put in some color pigment. Yeah, to make it consistent.
It's not, we are dealing in nature.
Yeah.
Sometimes we can't.
You want darker, you can put some fire.
Yeah. Because right now,
Will it affect any property of the cement?
if, okay, right now we talk about these moderns compared 100 years ago. Because right now a lot of times they can actually change the ratio. Over 100 years ago maybe it's quite fixed, but right now with technologies nowadays I think we can change the ratio. Like how they want to change. Because there's also one, they call it a performance materials with the same 5% generally. They add in anyone can answer other than you?
Limestone.
Yeah, limestone. Because limestone basically you do not need to go through the burning process. They just add it in, become your end products. Yeah. But of course right now they also have fly ash, GPS, depends on manufacturers. Yeah. So ultimately they just want the objective is to save energy. Of course also to save cost, right? So this now, failure by answer, that is a type cement. So you have to use any one of it can be used. Yeah. So next, silica film. So silica films, anyone know what is silica film? You guys use silica film before, but now.
Oh,
ada bulan apa kan?
Dia just filler to fill up the gap.
Filler is also correct. I give you. But why you want to use high content?
To provide strength.
Right, strength. Yes, also. So I think to answer your questions, why you use silica film? Because silica film is actually a material which is 100 times higher compared to your normal PC. So there's one silica filler to cap up your entire, to make it your concrete more compact. Yeah. So because second thing, ultimately you use silica film to gain strength. Also, ultimate one is to improve the durability. Because most of the time people use silica film. Okay, strength is one thing, compact is one thing, but it leads to the durabilities improvements. Yeah? So generally, this silica film comes from silicon metals, which is super fine. Super fine. The density can be as low as 150. Yeah. So most of the time you have to use a densified silica film. Yeah. Because it's so fine. It's very fine. Buka saja memang aku habis. Yeah. So we have to use a densified silica film. So this is also the same. So you add, is a silica film is also a SCM. It require a secondary process, which it will act with these calcium hydroxides to create more silication. Right, so this one is the microscopic, how it looks like versus your normal OPC. So definitely it's much more finer. It's much more finer. Yeah, compared to this.
Sorry, so the strength comes from the size or the properties of silica, or which helps strength?
Mainly because of the size compacting. We are making the
More compacted and more higher density.
yeah, more compacted. The trend is more compact. It actually fill up the very small ones.
Get more in the concrete. So back to more dense. That's why we relate to the durability.
Yeah.
Because durability mainly because of the chemical attack or the penetrate to the concrete. Yeah. So that's why if let's say the concrete is more dense, so that's why you will lesser of these chemical ions to penetrate in the concrete.
Yes.
So memang mahal.
Yeah,
BMW.
Yeah, this one, yeah, is like BMW.
BMW is in the
Or for certain projects that they specify, you have to use. Yeah. But it's a good product. It's a good product. Not easy to handle, but definitely it's a good product to use.
Yeah, mainly depends on the project requirement.
Yeah.
It's not like people will not use it for normal concrete productions.
Yeah. Unless they want to make it like your HPC.
Yes, we see.
Yeah, they would definitely. This one is one of the materials that they definitely will look into. Yeah. Other than your others SCM. So what's the percentage usage like for Keat?
10%.
Below 6, up to 6.
Then max.
There's a
Standard.
maximum.
6 to 10, but generally more than 10 is become just no, it's not become just really a failure. And also it actually somehow you need more images. So
Because it's finer, so that's why
It's
you
very
need
fine.
more water and more chemicals.
you can go up to 50, but yeah, generally it's not that bad. Okay, fly ash. And you know what's fly ash? Semi precipitation, yes.
Life product of
Huh?
life product of
Burning corn, yeah. Yeah. So what's the replacement like? Generally, you guys, you know?
What's the thing?
Yeah, replacement, not more than 100%.
35.
Yes, correct. Generally not more than 35.
Yes.
Yeah, so mainly because of the reactivities of the fly ash. Yeah. So generally, fly ash from coil combustion. So I think markets right now, everyone know, has been acquired by the ready-mix competitors. Ready-mix competitors. Yeah. But why we use fly ash? Why? Not cheaper. Cheapest. Cheapest. It's cheapest. It's not that cheap, but compared to others, SCM or even OPC, it's the cheapest.
Yes, if you compare with cement, definitely it's cheaper.
Yeah, compared with the cement, it's cheaper. And in fact, calcium carbonate depends on source, but generally, fly ash is also the cheapest. Generally, maybe it depends on source, whether it's your source or depends, but generally, fly ash is still the cheapest. Because it's just, why is it cheapest? Because it's just a byproduct. Calcium carbonate, you still have to go through processes. You not necessarily use for only your concrete, can be used for other purposes. On fly ash, no way. They want to dump it to this concrete. But of course, it also has the plus point. Yeah. Yeah. So which is also improve the durabilities of your concrete. Yeah. But sometimes this fly ash also might depends on the activities of your fly ash as well. So sometimes might be good, sometimes because it's a byproduct which we can't control. So this one sometimes you have to really be careful about. You have to test yourself. If let's say you know a little bit difference, maybe you have to recheck, or maybe you have to adjust a little bit on your mix design. Yeah. So it's also a byproduct via the secondary effects. Secondary. So generally the strength similar OPC and fly ash, they also take more times. Yeah, to gain strength. Maybe it's not 1 day, maybe 3 days. So next slide, GGBS. So anyone know what's GGBS? Anyone? Okay, what's the maximum replacement like for GGBS? Generally. You can use up to 80%, but generally we try to not control at 75. Yeah, you can use up to 80%. Yeah. So GGBS is actually a byproduct from iron. Yeah. So I think in Malaysia there's a couple of suppliers that is supplying GGBS. So the function is the same. Use SCM. The main objective definitely is save cost, but also improve the carbon footprints. Yeah, on your concrete mix. Yeah. Because every 1 ton of cement produces 1 ton of CO2. By just replacing this, you actually save more CO2.
I
Yeah?
think it's costly.
Hmm?
It's costly than cement.
It's not costly, it's cheaper. If let's say it's more costly, that means they are selling more expensive to you.
No,
Yeah, the one
actually,
company is selling almost similar price.
Yeah.
But
There are some.
actually the recycling of it is the need of the industry.
Yeah, okay, certain companies, they sell more expensive because they use it for themselves or for certain purpose. But generally, GGBS should be a little bit more expensive because it's just a byproduct. Yeah, compared to your OPC, you have to go through the entire process to come up on the end products. Yeah. Okay, next, aggregates. So just now we have actually mentioned why we need to use aggregate. Because the cheapest material, yeah. So there's actually, first thing is we have 2 types of aggregate. One is cost, one is fine. So how do we differentiate cost and fine aggregates? Size? What's the size like? Anyone?
Lower than 4.5.
Last time is right.
Last time.
Last time is right. Anyone? Guess? How do we define a cost aggregate? Sana, ada? Cost aggregate, fine aggregate. How do we define? Sieving. What's the size like? Particular size like for cost? Okay. For just to let you guys. So to check the size of particular size of aggregates, we measure by upper limit and lower limit. So upper limit for cost aggregate is the lower limit. I remember. Huh? Cost aggregate cannot be so that fine. Under the new code is 4 mm. You are right. Last time is right. 4.75 is right. But right now under the new code, again, standards is only 1 mm.
Later you can share the new code and the difference between the new code and also the
I can show you the new code.
later. Yeah.
So anything for fine aggregates, anything more less than 4 is called fine. Yeah. So this one you also have to remember. Yeah. Because if not, what is fine? Oh, this one also fine, that one also fine. I see a Tyson told that one is fine. It's not. There's actually a guideline to differentiate what is fine and cost. So anything less than 4 must go fine. Pasti kita senang cakap. If let's say you go there, how do you differentiate? How? If let's say consultant, macam mana? You cakap 5 or 0.5, then you get screwed immediately. Yeah. So this one is some of the parameters that you also always have to remember. Yeah. The fine or the cost. So in concrete, we also depends one shape. So what type of shape is preferred to use for your concrete precast? I would say for precast, I would say not binding. The interlock is much more better. Interlocking. So for angular, it's much better. For rounded, I think right now I would say you guys still can get rounded aggregates. I would say
Depends on quarry actually.
rounded or angular.
Usually SI, right?
No, the rounded aggregate, just cost aggregate.
Oh, okay.
So far I never seen any.
You can get at the sea.
So far I've not seen rounded, but I doubt right now people still use rounded, which is come from natural, which unlikely they can use all from quarry. So which is most of the time is angular. So rounded, what's the benefit? If let's say I want to use rounded, for example, if let's say you got a chance to use, what's the main advantage?
Workability.
Yes, workability. Right.
Finally.
Yeah. So one of the reasons why because of the shape of the aggregates, it become more easy to follow, especially you want to do a flow mix versus angular or flaky concretes. It's more easy to be achieved. So flaky concrete or angular concrete, you best use flaky. What percent? Why? Okay, why? I don't ask how many percent. Why? Why you don't use flaky concrete? Any reason? Because the reason is simple. Impact effect. Impact of workabilities. All the materials, like I said, most of the time that we select, we go back to the fundamentals of why we shouldn't use it. Yeah, but flaky, let's say like thick piece, really, flaky is how thick lah. If let's say really thin, immediately impact this. Yeah. So there's different type of aggregates. If let's say you guys use experience, there's lightweight, normal weight, heavyweight. Yeah. So I think most of the time for precast, you guys use normal. Unless you have certain different type of application for precast, they also use lightweight. Yeah. Heavyweight for different type of applications. Yeah. Heavy industries, they might need heavyweight. So talk about this type origin. We have artificial and natural. So one question, Emerson consider natural or artificial? Emerson. Answer. Got 50% chance. Betul.
Artificial is artificial or natural?
What's the answer?
What you guys artificial?
Artificial. It's not right, but it's okay. So Emerson, what's the difference between artificial and nature? Artificial is that you have to go through a certain process, burning process, then it can become artificial. Emerson is become from nature. You just crush it, it's Emerson. The origin is still from nature. Origin is from nature.
Yeah, you're not in the property of the characteristics of the material.
Water, cut down the water. Yes. By the name itself, water reducing nature. The main function is to cut down waters. Yeah. So why we need to cut down waters? Lead to your next answer. Reduce your water seep. To enhance one of the properties to enhance the strength of concrete. Yeah. So what is chemical engineering? So chemical engineers. So a lot of times people feel that once any issue about concrete, you ask put in chemical and dust magic and dust on this. Yeah, on modern concrete engineering or concrete technologies, this one become a very precious component. Even though it's very small, but it can really enhance the properties of your concrete. Yeah. So just now what I mentioned, if let's say originally you want to get a slump from like this KLCC to a flat slump, yeah, what do? You have water, right? Traditionally, so with the help of emissions, you can add a little bit, you can actually get this kind of workabilities that you desire. Yeah? So under the code EN934, so anything that is out of the four components is part of the MHS. So whether it's chemical or minerals, it's still part of the MHS. Yeah. So anything that can improve the properties of your concrete, that's the function of MHS. Yeah. Whether it's laid, fresh concrete or other concretes. So under the chemical engineers, there's several types of admixtures that we need to consider. Yeah. So what first one, just now we have actually mentioned, air and trainings. So I think for precast applications, generally it's a big no. We don't use air and trainings. So air and trainings is always for freeze and toast. Yeah. For weatherings, cold weather is coming. countries, yeah, that has experiencing
Probably plastering, cement plastering and
they add it a little bit, but that one is for the other functions.
the other purpose.
The other purpose, I do not want to cover that part,
Yeah.
but it's for the other. But
Yeah.
generally,
Yeah.
yeah, for A&N trainings is for field central.
Yeah.
Yeah, so the one that commonly that we use, the second one is water reusing. I think all, I would say 80% or even 100% for precursor, they use water reusing images. At least minimum, yeah, they will use. So the third is accelerating, but by the name itself, it accelerates the concrete. It means the hardened concrete, I mean it accelerates times to develop the strength of concrete. Yeah. So fourth, retarding. Retarding precast, unlikely you guys use it, but by the name itself, we actually prolong the setting times, prolong a little bit of the localities of the concrete. Yeah. So hydration control. So anyone know about hydration control? What does this chemical do to your concrete? Anyone?
Beats out excess water. Is it beats out excess water?
No.
It is human hydration.
Yeah, it's related. So hydration control is related to that part, but why do you want to put in hydration
Why
control?
you need to control the hydration?
Heat generation. To control the heat generation.
Heat generation is one thing, part of it. So I think that's how you have actually mentioned. Actually, this heat hydration control for certain application, they might need to keep the concrete fresh for maybe even 2 days or 3 days. Because at a fresh stage. That means after 2 days, you are expecting the concrete still workable. For example, you are batching 200 slab. Fresh, 0 hour. After 3 days, tarik slab, still 200. So for a certain application like dam, like they are doing big dam or tunnelings, so sometimes they might need hydration control measures to make sure that they have always consistently get a fresh concrete. Because they can't forecast whether what's the condition of the tunnels. So there's one images they can actually make your concrete stay fresh for a long period of time. So what happens is after you add it in, you add activities or to activate back the concrete. So it actually resume back the behavior of the concrete. Yeah. So there's one type of images that can actually use in future. If let's say you guys got, maybe this is one of the images that you can consider.
Is it more like the thing which will put it in the dormant stage, not too late?
It's at the fresh concrete. You add it together with your images, but the application is different.
What is the difference of retarder and hydration control management?
Retarded. So why is it retarded? You answer me.
Retard the hydration.
Yeah. So by the name itself, you already know it only retards the concrete, but it doesn't control the hydration. The hydration process still kick in after certain times. That means after for retarders, maybe it actually it retards concrete maybe for 1 hour, 2 hours, but the hydration process still come in. Once the crystal formation started, the images actually lose its functions. Yeah, it doesn't function anymore. Yeah. So that's the main two differences between hydration control and retarders. No, it's totally two different images. Totally two different chemical images. Yeah, it's a two different product. So my second question to you, my one question: what happens if let's say you put more retarders in your concrete? This one you mentioned, right? Depends on how many percent, but generally, if let's say it's not excessive, the concrete it takes more time to set. I'm not saying it won't set; it will take more times. Yeah. So if let's say the concrete, for example, you double dose after 1 day, 1 day of time or 2 days of time, 1 day I'm assuming you put in maybe double dose. So what do you do with concrete? Generally, because they put in retardants. You hack it.
Do it more. We wait for a longer time.
Yes.
It take longer time for to demolish.
Yeah. That's the answer. So generally depends on application. If let's say times is allowed, the only thing is to wait. Because anyhow, the amateurs, once the hydration start kicking, the function of the amateurs will actually be off. So the only thing, if let's say you can wait, you just have to only wait for the strength in. There's nothing much you can do. Unless you want to remove the entire slab, which maybe can cost you 10 times or depends. So that's why generally we just wait. Nothing much you can do. Yeah.
We can double check with the tip strength, whether it's okay or not.
Yeah, that's even more precise. Yeah.
If you want to remove, what I did is we use the high power water jet to wash off, so I keep my steel, the reinforcement, rather than I throw
The waste that
the settling at the side.
Yeah, so it depends. It really depends. But generally, times a lot, you just wait. Nothing much you can do. Yeah. So I think the next is corrosion inhibitors. So anyone know by the name itself?
Is it similar to waterproofing?
The concept I would say is not really similar. It's a bit, but it's not the same. It's not the same. So corrosion inhibitors mainly is to protect the steel of your concrete. Yeah. For waterproof concrete, you want the concrete to be waterproof. Yeah. So in a way, okay, if let's say your concrete is watertight, your concrete steel, the lifetime, it can actually stay for longer periods. It actually improves, but the function is totally different. Yeah. So corrosion inhibitors mainly is to protect the steel. Yeah, 100% for steel. Yeah, but of course it will have certain side effects, but it's not a thing. So that's the next is shrinkage, reducing amateurs. So by the name itself, actually to improve the shrinkage, yeah, to reduce the shrinkage. So let's facilitate reactions. You actually, if let's say for certain scenarios that you find you have these reactive materials, you can actually use amateurs to actually protect it as well. So last, the line will be coloring amateurs. So anything like just now, Philip has actually mentioned pigments. You want to pigment your concretes to be more grayish, or pink color, or red color, blue color. It's one of the amateurs, coloring amateurs. So the last one, special amateurs. Anything is not under this is called special amateurs. Yeah. So anything, let's say you want to improve the durabilities, you wanna have the bonding, routings, anti-wash amateurs. Yeah. So it's part of the special amateurs. Okay. So normally for chemical amateurs, the usage is very minimal. Generally, it's by liters, so it's only maybe I would say less than 1% or even 2% of your total concrete mix. Yeah. So you guys know how to calculate amateurs? For example, any reference you guys use? How do you use amateurs in your concrete?
Percentage over the cement content.
Yes, correct. So generally we measure amateurs versus cement content. Yeah, cement content. Total cementitious content. Yeah.
The binder or the cement?
Total, but it's part of binder is part of the cement. Yeah. Total cementitious, whether it's SCM or yeah. So it's part of it. Yeah. So it's generally measured by cement. Yeah. So the range can be from 0.2 to up to more than 2%. So one thing to highlight is if let's say if possible, any things that you use more than a million cube use more than 3 liters, you have to take into consideration that water is also part of the mixing. Yeah. So that's one thing maybe I would strongly recommend. If let's say we use a lot of waters, amateurs, then you have to consider into your mixing considerations. So amateurs, we use amateurs in different space. Yeah. So the first space, would say it's during batching plan. That means if you're batching, the first generally you want is on saving, right? So you want to optimize, you want to improve your workabilities, you want to cut down the cement, or you want to reduce the water cement ratio. That's the first phase. You use water reduction ambitious. So the second is on opening times. It's like I mentioned, well, we need certain time frame for the concrete to stay fresh for a certain period of time. So we need this workability retention averages to stay fresh. So in Malaysia, we guess what's the longest retention we have done in Malaysia? Generally, 24 hours, not really that long. That one is they will generally go to hydration control. If let's say they need that long,
4 hours.
4 hours is very normal.
And, 4 hours. Typically it's 4 hours.
Yeah. So
typically.
in Malaysia, typical retention, especially in KL, you need 3 to 4 hours generally. Yeah, because due to traffic. So that's why this one, so that it's become very common. Used to be not so common, but right now it's become very common. Because you want to make sure that the product that you delivered is still in fresh shape. But I think in Malaysia there's the like bridge project, 10 hours is very common retention.
Yeah.
But of course, setting time might be a little bit different.
Yeah.
But still, it's can be achievable with just normal retention averages. Yeah. So the third one is strength developments. So under strength developments, there's 2 parts. One is the accelerators and retarders. Yeah. So by the name itself, you know, if let's say you want to have like precast, I want 3 hours to achieve certain strengths. Because we know that, for example, might not be possible. I would say before 6 hours. 3 hours is not great. So you chuck in a lot of accelerators. You might get a certain different setting. I would say accelerators, there's 2 types also. One is for hardening, one is for setting. So for setting, you want like shotcretes. Once you spray, you are expecting the concrete to stick at the wall immediately. Yeah. So that's the application of accelerators. Retarder, you guys know. So durabilities, that's another measurement. If let's say for certain application, you need durability enhancement. So instead of adding for SCM, you can actually use MHs to improve the durability of the concrete. Yeah. Okay. So water reducing MHs. Anyone want to know what's the highest water reductions that we can achieve with normal, with the technologies of PC or water reducing MHs? The latest lah. Anyone? Any guess? Tak ada betul salah.
With the percentage?
Percentage of water.
Oh,
The highest lah. You can guess lah. Any numbers lah.
okay. Reducing.
Huh?
30%?
That one is not too low.
Too low.
Too low. You can. What's the highest water reduction you can get with the technologies? The current technologies. Huh? Anyone? Any guess?
60%?
Huh?
60%?
More. Yeah. Yeah. Too high. Answer right now. The technologies. Too high. So okay, that way. So the right answer is right now with the technologies, the new polymers that we can is available in the market is 55%. The highest. Yeah, 55%. That means for every 100 kg of original mix, you can actually take out how many percent water? How many kg waters? 100 kg waters. You take out 55. So that's a lot of waters that you take out in a particular mix. So water become and you are not only making your concrete more sustainable, but you're also saving the environment. Yeah. So when you talk about water reducing emissions, we obviously link this. We also mentioned about the dispersion. We also talk about this dispersion agents. So why dispersion? So when you mix your cement with water, what happens to your cement? It floats. It floats, yeah. So what do you need to do to make your concrete workable? Generally, you add water. Let's say without super plus. So what happens is you add in these admixtures to actually disperse out the flock, the cement particles, to give out more free waters for further hydration process. That's the concept, yeah? So there's few types of admixtures: low range, mid range, high range. So generally, with a certain same percentage of admixtures, like just now I mentioned, 55%, 30%, 10%, the performance might be different. Yeah, this one comes from old pictures, but generally, conventionally, you add the older generation with maybe like 10% water reduction. Maybe you only get this out of the disease. Like with 55%, this one can be achieved. Yeah. Okay, when we talk about admixtures, chemical admixtures, what are the great histories? Anyone guess what has been used for chemical admixtures? Plant-based, yes. We talk about maybe not now, 100 years or 200 years ago, or 500 years ago. Coca-Cola 500, I think.
Wow.
It's not that common. I'm not sure whether Coca-Cola is started.
We need to highlight Coca-Cola later.
Yeah. So I think so for very olden technologies, they have actually discovered sugars. It's one of it. Yeah, they use sugar. Yeah. So there's one thing in China they use a lot of concrete. Olden days. Blood is also part of the whether they kill people or not, I'm not sure. But they use a lot of bloods. Yeah, it's also part of the it's actually make the concrete more viscous. Yeah, so they use blood. Yeah, as part. Yeah, yeah. So a little bit of history of admixtures. So the first gen is called what we call lignosulfonates. So like what you mentioned, come from paper, lignins go through a sulfonate, sulfonated become lignosulfonates. Yeah, so when times move on, they modified the lignins or the lignophile sulfonate become modified lignosulfonates. Yeah, which they can actually control the parameters of these retardations properties they can actually control. So the second generations is melamines. It's not popular in Malaysia. In this region, it's not particular in Malaysia. Any reason why? Melamines. The slum loss is very fast. You use melamines, so that's why generally our tropical countries we don't really use. So the water reducing that we use the most, I would say 10 years ago, is methylic sulfonate. I would say 20 or even 30 years ago, BNS, very short. Yeah. So I think right now I think for precast, naturally it's good, but it's not good for environment. Second, it got its own limitations. So anything grade, I would say any grade more than 60 is a challenge. If let's say you want to use for blended cement, it's a challenge. Yeah. So that's why right now BNS or Nathalines admixtures has become lesser and lesser for maybe it's only for those smaller plants that produce low grades. Yeah. They still use Nathaline. But the main one of carboxylics until right now is still being very popular. Well, of course we have nano polymers nowadays, but we don't really touch on it. But right now, it actually develops polyalkyl PAD, nano. I think the one that you guys use also is one of it is nano polymers that you guys use. So, but PCE is still popular because of the customization. Or it can be polymerized into different products that you guys want. Versus the older generations, it's fixed. Whatever you given is fixed. Yeah, nothing much you can actually do. Because if let's say you want to have a longer retention, shorter setting times with ethylenes and lignos, can't really achieve. Maybe you can adjust a little bit of, they can modify the lignos or ethylenes, but it has its own limitation. So that's why this PC until right now is still very popular in the market. Yeah. So this one is the water reducing flour, but right now with navos you can actually go up to 5%. Yeah. So this one is we call modified lignosulfonates, 15%. Ethylene 25%, PC 45%. So later you guys actually bring in some samples for you guys to play around. You guys can feel how does this water reduce the impact on your concretes. Yeah. Alright, so water reducer, actually there's 3 functions. Anyone can give me 3 main functions. One, I think you guys already know, to reduce water. To reduce water is good. Once you reduce your water, increase strength, yes. One is to increase strength. Because once you reduce your water in your particular mix, water C becomes lower, and then your strength becomes higher. So what's the second function? Water reducer. Lubricity. Give chance up, bro. Give chance up. No, you think good. Yeah. So also yeah. So I think this good. So I think you're right. Ultimately, once you add in these additives without trimming any waters, you get a better workable concrete. So what's the third one? The most important one, the Philip always one. Philip, how to say cost? How does it cost? How does it cost?
Less cement.
Use less cement.
Yes.
So that's 3. Why we can save cement? Why?
Lower the frequency, higher strength, cut down cement.
Okay. So at
ICT no one.
okay. So the theory behind why we can actually save cement is for certain particular grades. For the main function is to reduce water. So once you reduce water, for example, from 100 liters, you reduce to 80. The water C also reduce, but you do not need. For example, you do not need to reduce water C. You still can maintain water C. So what's the next parameter you can adjust? Cement. So once you adjust the cement, the price go down. So that's the theory behind why you can actually save. It's not saying that you letak terus boleh save. No, that's a theory behind. Yeah. So there's 3 parameters that obviously you have to adjust. Water C equal to a strength. So once any parameter you adjust, it can actually correlates to 1. Yeah. Okay. So for example, in this one I think it's a free answer. I mean free answer for you guys. For example, for MHs, 1% of 400 kg cement per meter cubes. How much of MHs that you require? Anyone? It's straightforward. So not dapat.
Siapa belum jawab lagi?
Siapa belum jawab lagi?
Johor punya belum.
Yeah, generally there's two ways of measuring. Let's say they measure my percent or by this volume. So generally is I would say in a market they measure by volumes. Yeah. So how many ml per 100 kg cement? Yeah, for example, 500 ml per 100 kg cement. For example, okay, this case one more give. I use 0.8. 800 ml per 100 kg cement. What's the emissions I need to use for this mix? 800 ml. 800 ml per 100 kg cement. It's very. If you use 400 kg cement,
Berapa persen?
800 ml per 100 kg cement is required for this mix. And then this mix you only is 400 kgs. So how berapa emissions yang kena require 8 liters?
Tadi 1%, now 0.8%.
0.8%.
So cepat, cepat.
I prepare for you. Calculator. 0.8%. No, 0.8. 800 mil. 800 mil. You can give by liters. Also can. No issue. 0.8 liters per 100 kg cement.
Okay, it means 0.8%.
0.8%.
Yeah.
But this round, because the market generally we don't use by percent.
Yeah. They're more familiar with the term like 0.8%.
So in the law specs, like if the bike spec is, so I change the way on just change the way of asking. Proper. You've done one more?
0.2.
Kira kira lah.
800 ml per
100 kg cement.
100 kg cement. How many? The question is
So in a meter cube, how many emissions that is required? In liters or in ml?
Oh.
Yeah. Or anyone want to help? Per 100 kg. You are using 400 kg.
400 or 100?
400. You are using 400. You are using 400.
400 is 0.4.
Per 100.
Kali 4.
Kali 4 lah.
Kali 4.
But they have situ where they have gerak a bit. The whiteboard. The whiteboard. The whiteboard. The whiteboard.
Yang kita matching.
Apa I
kg cement. Normally they use in the market they use ml or 800 kg.
800 ml per 100 kg cement.
0.8. They used to 0.8.
Mix. So total I mix in ml or liter. Okay, berapa?
Dah.
Boleh. ml or liter? Is it tricky? Not tricky.
No, but this one is a general market spec.
This one is general, just to make sure that everyone in future you guys look at
Know
it,
how to.
you also understand. Not necessarily in percent. So, most of the times you can measure in percent, but in the markets, some I think they will somehow put it in such a way. Yeah.
This is a question for class, from 1 to form 3. Because why? My son is doing all this. So I said, the next? What's the question like?
Understanding and don't stick with our current practice.
You understand what
actually the theory behind and why.
Because I think a lot of times, yes, we measure by percent. It's quite easy, 1%. In market, I think generally in water, we measure water reductions. We always benchmark by 1%, which is quite relatively easy. Like 200 kg, you use 4 kgs. Yeah, or 4 liters. Depends on the density. So this one, any guess? Yeah, 3.2 liters. Managed to get it? Apart. Because okay, there's one thing maybe I've not really emphasized quite a lot. Because a lot of times for amateurs, we always measure by per 100 kg cement. It's not per kg cement. Per 100 kg, how many 100 kgs do you use for certain volume of amateurs? So you are using 400, basically you just times 4 lah. I mean, or if let's say you want to okay, 100. I use the okay, I use the max way to easy, okay? Okay, you need how many ml? You just multiply 400 kg times 800 ml. 100 kg cement. So you cut.
ML is X. Let's say X. Yeah, I want to find
You cut.
Divide X.
4 times 800. So I think the first concept, maybe I have not, maybe it's by mistake, so I have to give you the tip also. Yeah. So I think generally in amateurs, to make it clear, is we always measure by 100 kg cement. Yeah, I thought maybe you guys get a little bit confused. Yeah, it's my fault. It's my fault. Yeah, it's not easy. So generally, it's quite often you can see. Maybe it's not 800, maybe 1.2, 1.3. For precast application can go up to 1.6. Yeah. But generally, we told for amateurs technologies, we try not to use more than 2%. Because if let's say you use more than 2%, personally, I would recommend you to use a different type of amateurs, or even a better performance amateurs, or a higher water reduction, water reducing power amateurs. Yeah. In a particular mix. So how does this amateurs come from? Just now I've actually mentioned big nose. Basically come from paper waste. The olden days for naphthalene sulfonates come from leather. It's a byproduct of leathers. Yeah, they're actually sulfonated to become naphthalene sulfonates. But right now, for chemical amateurs industries, they actually do the polymerizations. That means they produce the polymer by itself, yeah, instead of getting from the byproducts. Other than lignos, I think basically the rest, there's a lot of factories that do polymers for amines. Yeah. So just now I've actually mentioned 3 functions, main functions. 1, increase the workabilities. Second, reduce the water demand, increase the strength. 4th, you have pole properties. Yeah. Okay, this one is a simple graph. How do you actually use these arrays, which can actually relate to what I've mentioned? Yeah. So this one is the control mix. Once you add in number 2, you cut down waters. What happens is you actually shift the entire graph to a lower water C. So by definition, lower water C means higher strength. Yeah. So on top, you are just purely inserting these water reducing admixtures. It actually improve the slump. So there's one scenarios that you want is you can have both, right? And there's a little bit saving on savings and also the slump. You can actually do that, or you want to maintain the water C, you cut down the waters, you trim the cement. That's the ideal. Yeah, because I think Philip will say, okay, I want to use 55%. Cut down, go as low as 0.22 water C, cut down the cement. So that's the some certain applications that you can actually achieve by using water reducing admixtures. Or you guys want to do one quiz?
Quiz, huh?
Quiz. Okay, for given admixtures, for example, this one. Okay. Quiz again. To make you guys understand a little bit more how saving can be done. Yeah. Water C, cement. For example, on a grade, there might be
grade 60.
grade 60. Okay, what cement? How many cement you guys want to put? 500, 500, 400, 450.
Let's say you put
500 lah. Okay. Cement. Water C.
Okay.
0.38. There might have absolute. I think on a given, I might have put higher. Put higher.
Idea.
Okay, I use for example, water reducer admixtures. You have 20%. Okay. What's my new WC? Sandy, you know answer.
Johnny also cannot.
Definitely see cannot. What's the new WC like?
Water reducer. The key point for
Also, I'm missing one thing lah. Ini you kena calculate yourself lah.
Hey.
Give tips lah, give tips lah, give tips lah. Boleh dapat. Saya belum calculate lagi. This one is impromptu, never mind. Then I give you 2 gift lah. Esok saya bawa satu gift session. Then siapa dapat?
Kalau betul dapat.
Dapat, mesti dapat. I give you 2 times 2. I will hold you for you, special gift. Special.
Admission.
You request for free sample. Free sample.
Milliliter is one. register chemical. Boleh letak ini this one dapat.
Betul. Okay, so how it works? Special. Okay, on a given mix, how do you save cement? This one I mentioned previously, right? I've actually highlighted. Anyone can volunteer. Show us how do you save cement based on this.
0.4 minus 0.2 times 600.
Show. I haven't calculated, I can see. You can bring your calculator.
Just decline my calculation.
How do you save cement based on this info?
I will ask you what is the required slump?
Requires slump. Okay, assuming the slump is the same. Yeah. The first criteria is assuming slump is the same. That means all the parameters is the same. Assuming the aggregates, the packing size doesn't affect you lah. Assuming the rest is constant. Yeah. Even assuming by just changing you can actually achieve, but in fact you have to do a little bit tuning. But for this practice, we just want to know as an idea how do you save. How do you save? This one I mentioned to you, right? I have actually give out the hints. Just want to see anyone.
The answer is
Got anyone listen to my formula? Anyway, how do you save? How many cement that you save?
120.
120. Anyone new person? Ada lagi orang? Since your answer, I will call you something special.
No admission, understand?
No. Definitely.
So while maintaining WC,
How many cement that you actually save?
now is 192. So WC is no. WC is 0. Raw material 4 so 0. So C equals to 4.
That's how you. So just by
Assuming WC
assuming WC is the same, assuming the rest parameters is constant, by just using MHS you can actually save 120. But this one is a concept. It's not necessary in a mixed design you have a lot more influence. But as a concept, you can actually do that as your benchmark, as your calculation.
So this is like, let's say the 600 kg cement quantity is for, see, without chemical.
Without chemical.
Yes, just purely cement water.
Yeah, purely cement water.
Yes. If
Because-
with chemical, then you can get lower cement with the same WC.
Yes.
I think aggregate and center will affect also.
So that's why I say a lot of times, whatever we show here, at least is a guideline for you guys. So compare for plain concrete without admixtures, even though admixture and admixtures, you can actually do the comparison, but it will be a little bit more complex. Yeah. So I don't want to just confuse you guys further, but at least you guys get the concept. How this admixtures water reducing works for 3 functions. By just reducing, you can actually increase strength, save cement. The third one is improve the workabilities. By just adding on, your slump actually improve. Yeah. So that's the 3 main functions. But this one just thank you. So this one is just a guideline. Yeah. So anything, but of course, like one mentioned, sand. Because once you take out binders, you might need to adjust your mix design. Yeah. So there's a lot more properties that you have to take into consideration. Yeah. Okay. This is what I meant. You guys I believe you guys already know. Yeah. So 1, water C. Cut down water. you save, reduce water slip, you increase your strength. Yeah. Next, you improve your, you use a high water reduction, you get a further lower water slip, which lead to higher strength. Yeah. So there's different comparisons. Yeah. You use different like water reductions, 20%, 10%, 30%, 35% difference. So this is what I mean by, if let's say you look at the one of the actual result. Yeah. So one, you improve the slump. For original mix, you add in just admixtures from 100 to 150. So the second consideration, from 0.55, reduce to 0.5, you get a higher strength. Yeah. Third one, you cut down the cement cost, cement saving with the same slump overcomabilities. Alright, so right now I'll go into the mechanism. How does this admixtures work? This is how I actually mentioned when you put in cement, when the cement productions has actually finished, there's the cement particle carry charges. It's either positive or negative. Yeah, that's the mechanism. Yeah. Once you add in water, the materials flux. So there's a lot of entrapped waters still remaining in the cement particles. I mean the cement, the flux. And the water cannot be hydrated or cannot be used for further hydrations. So what happens is, the first and second generations of admixtures, which is ligno or these nathalines, it will actually induce charges to your cement particles, which is mainly negative charges. Yeah. So what happens is, when you have negative, yeah, you push. So you push away all the cement particles and free up the water. Yeah. So that the water which is trapped or flux inside the cement particle can further hydrate with other cement particles. Yeah. So that's the concept. Or this water can be also used for concrete water or what? Workabilities. Yeah. So that's two main functions. Yeah. So that's the objective that we want to achieve on water reducing admixtures. So once the water release, it can actually make the concrete more workable and actually further reacts with the rest of cement particles. Yeah. So over times, when this CSH formation started, your admixtures properties or the function of admixtures actually will be absorbed. Yeah, in a way. Yeah, it will stop the retentions or workabilities that is actually mentioned. Yeah, so you form the CSH gel, and then yeah. So this is the conventionals that I mentioned: lignos, nathalene, induced charges, and then by times grow, these charges will actually lost. Yeah, been hardened. There's no charges anymore in your concrete base.
How much charge it will?
Huh?
Normally, charges go away. Like
What?
put to the water, then a mixture,
Mhm.
SP. So how much time it will remain the negative charges? 1 month.
Until this, I would say, once you observe the slump loss, basically the hydrations, I mean the effectiveness of the admixtures has been lost, I would say.
Like
And then
10 minutes, okay.
I would say depends on type of admixtures. Yeah, generally 30 minutes or 1 hour. Yeah, depends. Yeah, 30 minutes I would say. That's 30 minutes to 45 minutes.
Alex, I have a question. Can we reduce, because the crystalline grow bigger and bigger, the charge or the PCE, the backbone are already inside the crystal. So can we reduce after some time, reduce SP or reduce retarder? That would be interesting for the applicator here.
Anyone?
Can we reduce now the slump already dropped. Suppose 150 not suddenly, after
How many
1 hour
hours?
become, after 1 hour, 1 hour it becomes 75. Can we reduce additive SP example to make the slump go up again?
Or put water lah.
Generally at site, the site worker they will put water. Okay? But in our case we are professional. We do that. Okay.
Water, take water out.
Yeah, this is the question. Already start crystalline because it already, when it start crystalline, you already bounded some of your PCE or naphthalene or any additive. So now, can I reduce? The question is, reduce another certain amount of SP?
No. I think no.
Any more questions?
No.
Any more answer? Any more answer?
No.
So I would say for it depends. It depends. So I would say it depends for case by case. So if let's say it's already totally hardened or fully set, so there's no point for you to add it. If let's say the slump, for example, from 100, 200s lost to maybe 180 or 170s, there's a possible you can add in reducing. But it have to be done by professionals, trainers and engineers, because you need to know what's the percentage of the dosage that is required for you to improve.
So the same as we were adding in the switch. Because the calculation has been started, the CSS gel has been created.
So that's why I say it depends on.
Forcing it to go out.
Yeah, it depends on the stage. So if let's say it's already hydrated, there's no
You
point.
already final setting, we call it final setting time. So if you achieve the final setting times, concrete normal, workability, and elasticity, all this, so you cannot do anything with the concrete. We already formed the crystallization of the concrete.
So when it's just by the loss of when it's only the negative charges has been actually lost, you reduce maybe. I would say you still can actually improve back the increase back the workabilities. You still can do that, but it's case to case. It's fully hydrated, no way. No way you can do it. It's hardened, it's already set, so you can't do anything.
Is it a good practice if we are doing the mix, then we get SP to get the slump, like say 120, then you take it from the machine. The slump is not 120, it is 80. Then you add more, give more minutes. Then
You actually can do that. So that's why I say it comes with experience and has to be trained engineers. So of course you need to know what's the percentage that you need to add to get certain workabilities. For example, for 100, I know, okay, I want to achieve 120 or 130s. So how many percent? So not everyone can do that. Because not everyone know how many percent of MX for particular, for 20% or 15% water reducer can actually improve the slump. So but over certain experience, or you have done a lot of trials, you will know maybe like 100 mils it improve like 20 mm or 15 mm. Maybe within the periods of 30 minutes. Okay, you still can reduce. Yeah. For example, you still can do that, but you have to done your own research.
not 30 minutes, it's at the moment, like 5 minutes. You take back.
You can.
Normally we keep the data.
Yeah.
Actually, before all this reducing, we need to do a set of data. So after that, we give a small bottle of SP. So when the ready mix go on site, they face this problem, the truck operator, they can reduce based on the data we give them. Okay, not simply just reduce like that. I see some of you actually know this strategy. It's very good strategy. Okay.
Because sometimes because of slump you reject the entire concrete, it might not make sense. So sometimes, so for certain, depends on situations, you still can do the reducing. it's a good practice instead of like adding waters. Adding waters.
Better than adding water.
It's definitely better than adding waters.
Yeah, it's more applicable to the ready mix.
Ready mix. Precast also some
certain-
certain application, yes. Like if let's say you are making a big cast, open casting, yeah, they do keep a little bit of MX on their trucks. So it depends. But definitely it's a good practice. Definitely no adding waters and MX. Yeah.
Then what we will do if we have a big slump like 180, we need 120. So wait for it.
From 180 to
Yeah.
120.
To lose it. Or
Depends on practice. Generally, on application. So generally, the only thing that to do is to wait. There's nothing much you can do. If let's say the consultant really restrict to only 120s or 150, so maybe you have to wait for another 15 minutes. But generally, it depends on whether you also have to identify why it's 180. Because you design it to be 120. So it's either you are adding more super or more your moisture, you have not done your moisture corrections, you have not, or you adding more waters. Yeah, right. So that's why I say the first stage as a fresh concrete is an indication for you. If let's say you already know it's 180, then you have to be careful. You have to find why it's 180. Because you design it, you have done the practice maybe for 1 year, it's 120, right? Yeah. Alright, so this is how it looks like, yeah, before and after you add mixtures. So you can actually see the fines particles is actually dispersed into more fine. I mean, proper. It's not flux, it's fineness. Okay, so this one is just an indication. So on Super Plus, generally every percent you add in to improve slump, you actually improve different percentage or different mm. So you add 1%, 1.2, 1.3, 1.4. What happens is it actually improves the sound. Yeah, but over adding it might not be good. Later I'll show you why. Yeah. So this time I've actually shown, right? You have actually added super to cut down. You are expecting higher strength, but on a certain cases, after you add in too much, the strength drop. Any reason why? Anyone know why? Drop. Because you add, if you're given mix, you're expecting, okay, I add, water C should be lower, but anyone on this graph, why is lower? Overdose, yeah, is overdose. I agree. Overdose, what happened? Greenhouse effect, yes, it's also one of the answers, depends on the type of mix. But generally, if let's say you use more, anything which is over, it might cause bleeding or I would say segregation in this case. Yeah. So you see, because I've not shown you the products, the slump. Yeah. So it might happen. So not everything which is too much is not good. Like your cement. Yeah. Instead of like why I wonder you do your put 1,500 kg cement. Might not be good. it other side effect, yeah. Or your heat is higher, stuff to other. Right, so when it comes to PCE, the interesting about PCE is the chain of the PCE, the side chains. So the first gen and second gen, which is the Igmo and Nathalines, it only induces charges. Yeah. So on PCE, it has different type of change, side change, which it actually can improve further the workability or retention. Because this chain will actually repel each other when it coated to the cement particles. It's not only the charges, steric effects, it also have this side change that is blocking, repelling each other's. Yeah. So it actually for like slump maintenance depends on the length of change. For first gen, second gen, depends on mainly on molecular weights. Yeah. So for this, can be customized. You want it to be long, you want it to be short, the charges, how you want to make it be, yeah, the main chains. Yeah, so there's a lot of possibilities on PC. So that's why until right now, PC is still being very common in the markets because of the flexibilities of the polymer or of the polymers. Okay, so so this one is the first gen. So on a normal cement grind, it's actually it's charges by negative charges. What happens is when these two cement particles try to connect, they actually repel. But over time, this dispersion effect will actually lost when hydration started, like what I mentioned. Yeah. So this one is a picture that actually show you much more clearer. So this one is the first gen, column repulsion only. So when we introduce like this PC, it's not only columns, but you also have this direct repulsion, which come from mainly from the side chains. So PCE is very flexible. It's not only coated. So some of PCE, you can actually move freely under the water shape. This one is one of the shapes. Yeah. So PCE, there's a lot of, I would say, hundreds or even thousands of shapes. Some is like flowery shape. Some from flower, they actually expand back to the normal shapes, the comb shapes. Yeah. So there's a lot of possibles on PCE. So you can actually customize, you can actually change the shape of the polymers to customize to what you want. Like early strength, maybe you want a side shorter change to enhance the early strength. Yeah. So yeah. Right. So this one is the comparisons. On a normal mix, you add just only a water reducer. What happens is try to improve the workabilities, but over time they will actually drops. But with the different type of PCE, you can actually customize it in such a way that you can actually prolong the working times coming from the side chains. Yep. So this one of the charts. So if let's say you wanted your concrete, for example, you are in Sabah or Sarawak, today you are given your duty, and then you have to get your concrete from a batching plant. Unfortunately, yeah, if let's say it's not planned, for example. So you have to actually make sure that the concrete before and after, you have to specify what's the timeline that you require for you to do casting. If not, most probably when the time reach, they'll tell you, yeah, just now, this is what you specified 50 or 40, by the time it reach, it becomes 0. Yeah, because you have not specified given the time frame. So I think that's one of the things that maybe you guys also have to consider. So when you have you given a chance that you have to specify the time that required for your entire process. So this one cleaning project 8 hours, but right now 10 hours also is something very common in Malaysia. So this is what I mean by PC. Why it's still popular? Because you can actually customize the polymer by itself. That means if let's say today you want your concrete to be like a VMA, you want the concrete to be a little bit more viscous for flowing concrete, because you intend to control the weeds, you can actually put in different type of polymers into your PC. Polymerize the PC differently. Yeah. So you want to have retention properties, you want to have early strengths, you want to improve your late strengths. Yeah, it can be customized. So this is your normal ambiguity. So today, if let's say you intended to prolong a little bit of your set, shorten down the receptor time, you actually can change the polymers. Yeah. So the polymerize, it is very flexible in a way. You want to duplicate it, you want to shorten the side change. So until right now, the reason why PC is still popular, customization, you can actually customize whatever property that you want. With the improvement right now, we have MPPH, which is nanopolymers. You can actually further enhance all the properties, like water reduction, retention, early strengths, everything can be enhanced. Yeah. So I just give you an idea how BNS older generations water reducer versus PC. So I think for given amateurs, I mean for PC, depends on what. For this case, of course, it's a high range water reducer PC based. Only 0.3%, BNS 1.2%. So the dosage wise, just like I've actually mentioned, BNS maybe maximum water reduction 35%, up to 25%. It might be 30%. For PCE, it's 45%. So the first thing that you can actually control is the dosage. So dosage wise, you can see there's a lot of difference. The strength, so that's why it leads to the strength gain for PC also quite significantly different. I mean, it's much more higher versus BNS. Yeah? And of course, the retention time can be customized. Yeah, you want it to be a little bit slightly longer for 60 minutes, you can actually customize it. Yeah, versus Natalie, whatever you put in is fixed. You can't change. Yeah, it happens. It happens. You can't say, oh, I want maintain for 50 minutes or 30 minutes, 1 hour. No, whatever given is pretty much quite fixed. So with a given dosage, depends on water reduction. So dosage wise, of course with higher water reducing power, you can get a higher strength because you use a lot of waters in the properties. So this one is just a graph on how it looks like overall versus all the polymers from this older generation, lignos until PC. Yeah. So to conclude it, I would say PCE generally, I think right now become more and more common. I wouldn't say popular, more and more common because of these few factors. Workabilities, setting time, early strengths, for your case, especially early strength. Yeah, I believe you do not want to wait for 7 days for you to demo. Because right now, like precast, you want 1 day, or even 12 hours, or 8 hours, or 10 hours, depends whether you guys do querying. Yeah, so I think the requirements become more and more stringent. So that's why right now customizing of images also become very popular. Yeah, so to cater different type of needs. Okay, this one, underdosing and overdosing. Anyone can give me an answer. If let's say what happens if let's say you underdose your particular for concrete water reducing emissions. If let's say you underdose, what will happen? Anyone? Not enough charges. Yes, correct. Yeah, not enough charges. Yes, correct. Yeah. But what happened to your concrete, your fresh concrete, or hardened concrete? Strength apart, little. Completely, yeah. It's still come back to the same principle. If let's say you are underdosed, 2 things or 3 things you might not get it. One is your workabilities. You might be getting lower workables. Second, which you do not want, your strength, impact your strength. Third, for this scenario, if let's say you already save cement, you are getting the same workable, most probably you are adding waters. So what happens if let's say there are waters? The strength up or down? Down, right? So that's what we do not want it to happen. So sometimes on fresh concrete properties or even other properties, we have to be always take note on that. If let's say like your case, okay, how come I use the same thing? How come 180? Normally I only batch is only 100. So something must be wrong. Like it is underdose or overdose. Yeah, underdose for your case it's worse lah. That means they add lesser amateurs, but they add tons of water to get to achieve that water capabilities. Yeah. So, for example, this this is one of the site that is already spilling severely. Yeah, was one of the reasons the strength they did not achieve the strength that is required, and also they have not checked the durability of the concrete. So this is what will happen as like, let's say we did not really check properly. Yeah, especially on your strength, on your on these parameters on the fresh concrete. Yeah. So sometimes you think it's okay like the past, but on site, if let's say they go for like this kind of marine structures, which is important for them, but if we do not know what will happen, so like what you mentioned just now is right. Impact the slum. Okay, what happens if let's say you overdose? Segregation. Very obvious. If let's say for even same mix, you add in more, definitely segregates. Next, any more? Add in more emissions, what happens? Slowly improve your strength.
Waste of money.
Okay, so yes. Wow. Yes. These are sudah influenced by Philips. So I think anything which is more is also not good. Yeah, other than wasting money, you also might not be able to achieve what you specified, what's given. Yeah. So one thing, yeah, your slum might be more ultimate strike. If let's say it's segregated, yeah, definitely no. Yeah. Depends also whether what type of emissions that you use. If let's say you use retarded, concrete might not even set. Or even maybe one or two days. Yeah, you need to just only purely wait. Nothing much you can do. Yeah. So air and drain. For air contents depends. For different certain type of lignos or lignosulfonates, you actually generate A's. Yeah. So you put in more, your concrete strength also lose. Yeah. So that's the drawdown when you use more. Yeah. It's not purely on over slum or segregates. Yeah, that's also certain effects that you guys have to take note of. Yeah. So bleeds, just like battery show, you guys definitely is a no. But on other type of applications, minor leads is still acceptable. Yeah, especially for borings, they like electric leads. Without leads, they will say no. So it's totally different. So I would say different application. So this one is concrete, which is considered good concrete with no bleed, no segregations. That means the binders was with the aggregates is still intact. That means it's not segregated. Yeah. So what's the difference? Bleeding and segregation. Anyone can give me?
One piece of water.
Huh?
One piece of water on the surface.
Yes. Segregation.
Segregation aggregates of water.
Yeah. So I think bleeds water is only like what he mentioned. Bleed water is on top. But whereas segregation, that means the aggregates has been separated from resting and base.
Under segregation, we are more focused on the core segregate.
Yeah, cost segregation.
The
That means
other one is like paste.
yeah, based on surface line, minor layers, I would say acceptable is a very thin bleed is still fine. But I think for segregations, that means your cost and aggregates and paste is fully separated. That means if let's say you cast a concrete, you pour a slump, remember IE, the water will be right at the furthest cement base and aggregates. That means it's all separated. In short, everything is separated. So when you pour a fresh concrete, you will already know this one is segregated concrete. Yeah, by itself. That means all properties is that means the binder is not binding all. Yeah, in short. That means yeah. So this is a property that fresh concrete that later no. In any circumstances, no. Yeah. So when you use this, most probably what will happen is like segregation. Jika you force ni nak pakai, apa yang akan dapat? Complain for you. Why did not use? Why? Yellow card for you.
Very standby.
potong salary. Yeah. Yeah, one thing I think is what you mentioned is right, or you become porous. Second, I think ultimately most of the time you use this concrete, your end product most probably honeycomb. I would say, and it's not 100%, I would say 80%.
Yes, during, I mean, especially during the compaction time,
Yeah.
you can see the difference. You can see if after the concrete hardens, when you demo, you can see the concrete like layer cake.
Yeah,
You can see the aggregate, the heavy particle will go down, settle down.
Yeah.
You'll see the aggregate at the bottom, sand, and maybe paste on the top, and water maybe. Yeah.
Yeah.
You can see the difference. If really segregated, then you demo the concrete will look like that. That's sure it look like that. It's a layer cake, it's a layer cake.
Yeah.
Yeah.
So that's what we don't want.
Yeah.
Because you know, it's on in a condition that is the point. Your strength will not be good. It's not compacted. Yeah, it's fully it's not yeah. So that's what we definitely 100% always have to reject. Yeah. You don't take a risk yeah, on using a segregated concrete. Okay, so I think before we go for lunch, we go for as a summary. I think today we've actually covered a few main topics, the compositions of concrete. Yeah, we have studies type of cements, aggregates, waters. Yeah, so supplementary cements. Okay, for supplementary cements, what the percentage for fly ash maximum we can use? 35. Yes. GGBS. 80 maximum 80. Yeah. So okay. So what's determine the water? Why water cement ratio is important in your concrete? Strength to measure concrete. Yes, correct. So I think we also cover the chemical admixtures. So what's the three functions of chemical admixtures? Water reducing admixtures. One, improvability. Cut water, improve strength. Third one, reduce cement. So most of the times I was taught that cost number one, but it's good. Yeah, at least you guys are concerned about these the qualities. Yeah. So I think before we go for break, any questions?
I think just now the PCB, the one you mentioned, the shop, what do you call that?
The side change.
The trading, right? There you mentioned viscosity and all those other parameters. Okay, actually, how does that work? Because, like for example, those you say charge it with negative charge, disperse it. Okay, the one we understand. We can actually split out the cement particles more and all that. But on the charges, because why we also have that perception that PCE we can do all this, but we never understood why. Until like certain ones we realize that once we do double dosing of different type of admixture, then we can get that kind of parameter. But then when we try to build let's say different polymer and all that. But what is it in the polymer that does?
Okay, polymer. There's a lot of. Just now I mentioned is the side chains. So one of the reason, the difference, the main difference between the charges is they have this side change that actually repelling each other's. Also to improve the workability, that's one. So just now you talk about this viscosities, but of course that one is more to polymer itself.
Okay.
Yeah, the different type of polymers with different, you have different type of effects. Also the shape of the polymers. Just now this one, the whole shape is just one type of the PCE. Some shape is like flowery shapes, like curve shape. The side chain might be different. That means the side chain. This time I only show you a constant side chain length. So it can be very various. That means the side chain, some is long, some is short, some is mid, some is curly.
So in layman term, we can say like all these shapes will help to give it the rolling effect of concrete.
Yes.
In layman term.
Yeah, in layman term, yes. So it actually further disperse the cement particle for water reducing admixtures. It actually free up more waters and also improve the water retention because it actually keep on repelling. That means the water might not be the hydration have not started. You will not start so early. So this one, so with different type of polymers, it actually can combine. Like PCE, you can actually combine different type of polymer to become an end solutions. Yeah. So like PCE, like a curve shape, you can mix with a flowery shape to get the property that you want. So maybe the product that you get is not just only one PCE. Maybe it's a combination of like A, B, C, D, E of polymers to get the property that you want. So I think in short, it's a little bit difficult for me to explain the chemistry. Yeah, so I'm also not a chemistry, but the concept is in PCE you can actually mix PCE itself, different type of chain, different type of main copolymers, you can actually mix it as your end products. So that's why there's a lot of customization flexibilities on PCE. Yeah, so that's why it's until now still find it still interesting for PCE. But of course right now we use nano PCE, which is a further enhanced version of polymers. The one, the new version that you guys use.
Or the latest version.
IR.
Yeah, the latest version.
The latest of.
Even the 290 is also
290. 290.
Like
For the NLP 290, the so-called play edition.
yeah, that one is also one.
play the stabilizer.
The new version that you guys use also is we actually incorporate that. But it's not for me to punch and up today. And that one separately. We do it separately. So any more questions before we go for lunch? Okay, I think we come back. I think we have a little bit. We come back a little bit early. Okay, so we can end early.
Okay.
So how long you guys have a bit more different types? You can do it by all means. So it's all 100% for you guys. So you guys, each group try one type of animation. So start from Ignos, BNS, and PC. So you guys can once you have the same base of water C or water making sunflower, then you try to put in different dosages, or you want to place it at the same dosage, then you see what's the impact like on your base. Yeah? When you have similar base. So first speak part of 4 to 5% in group.
These two is the
No. This one is range. This one is ada marker pen.
I think kita buat ini satu. So 1, 2, 3, 4, 5. Oh, okay. 1, 2, 3, 4, 5. Sana mungkin satu grup. Form figurnya lah 4%.
Mix lah, janganlah sama-sama, mix lah.
Datang plan kita nak stick together. Friendship forever. Mungkin tak.
Okay, you guys come. You guys take nominate your own leaders.
So you orang satu kursi je lah.
So I think
Get your hands dirty.
safety, wear your glove. But I think it's fine because we have actually prepared for you lah. In the case that you want to feel the texture, you can actually wear gloves. Right? So you use this to mix because it's quite simple. You just add it, measure the waters, 15 ml. This one is 50 grams. You'll be adding 50 ml to start with.
Okay.
Then after that, you want to measure. Because this one is just an indication. Because it's just for you guys to feel it. So you guys try how many you want to get, then you buy it.
10 gram lah.
2 grams in one.
15 gram. 15 gram.
Yeah, you start with 15 grams.
You have water.
Okay. Drinking water. Drinking water.
RO water.
I just get one bottle to be enough for everyone. Okay. No need to pour out. Everyone take 15 ml. 1.5. 1.5.
Yeah, 1.5.
Okay. Eat over 50.
Yeah, to start with, then you add it.
You can have it.
So from there, unless you guys want to play a little bit more. Yep.
We need
Come.
to start now.
We need to start now.
If now you have let, you need to go home let.
If not, you go home by 7 o'clock.
No lah. Half an hour.
Okay, you guys understand? Understand, right? Okay.
So you need to know. I know you guys got experience, but you need to play.
Mana cement?
No, I just I can 70%. Okay.
Mana Dio? Mana Dio? Mana
You are professional.
Yeah.
Like feel like this. You should go for the seamless 1.5 corrosive. I think your laptop.
Boleh start
It's time to
because
change your
dia
laptop.
berapa
No problem.
Water.
Accident you call, then you change the better one.
15 ml.
Okay.
Okay, super fertilizer. Super fertilizer.
Okay, so you guys, once you guys done, you mix. 1.5.
Kalau banyak bang dalam tapak ini silinder kena kelipet balik betul.
1.5.
1.5.
No.
Small. This one is 1 ml, 2 ml.
Okay, take you for it. Okay, I think you guys, whoever is ready, you guys can mix. Start mixing first. Come.
Ini sekarang kita dengan masak buat cake.
Buat letak dulu. You letak dulu. From QC professional. Okay, another one. More.
I think
Never mind, it's okay. You guys just mix it.
you want to go for you? Susah atau tidak? Senang saja. Maksud saya dia susah atau Which one you want to put? Which one you want to put?
No, I think we separate.
Đây khai được con
This one, okay. Okay, so you guys can start with 0.5%.
0.5%.
Or 1%. Okay, make it easy, 1%. Make everyone life easier. So you can start with each group. 1%. So right now we have 3 groups
1%.
with 3 different type of admixtures.
100 is 1 gram.
You guys, 1
by gram.
50 grams. So you put in 1%. 1%.
I think you
This one PCE.
you need to put more than 1%.
So for your side, you put in 1% of water. We see the differences. Estimated lah. It's okay.
5 ml is 10%.
10%? Oh yeah.
0.5
Sorry. 0.8, yeah.
I think this measurement can measure one.
So can measure.
Oh, yeah,
What's the percentage?
0.5 is like that.
Always berapa? 0.5 boleh lah. Boleh.
Dia ada tasak lah. Problem is dia tasak. Local already. Masak. Bukan you lagi. Dia ada masak. Not clear. Boleh tambah mah. Boleh tambah.
Is it getting better?
Add water is always a good solution. Ini memang factory punya practice.
It's industry practice, don't worry.
No. Only you do it. I tak pernah do.
Tengok BCE sudah boleh wah.
Okay. So right now, what I need you guys to compare is you compare your mixes with other team. Because yours is with PCE, same percentage. So you can see what's the difference. So 5%.
PCE. You put PCE then
Okay.
here is naphthalene.
So this one is adding waters lah. So just to do another comparison.
That one is just pure water.
This one,
Definitely not.
PCE 1%.
This one is naphthalene.
just by adding 1% of water.
That one is what? Lignol L. Okay, each one of you can pass. This one is water. Okay, you see dia punya Milo sudah kau.
Ini bukan Milo lah. Ini mochi lah.
Saya mau tengok Natalie, mana Natalie?
Lignol talent. Lignol sabun. Macam ya, ini macam mochi lah.
Ini one of the best additives. PNS is naphthalene, second gen. First gen. Woi, yo first gen hebatnya. Boleh buat kerja? Boleh ya? Boleh, kita boleh, memang boleh.
So I think you guys can feel the different impact in terms of concrete.
Okay, now I have a question. If my sand contain high fines or so-called clay or silt, which one should perform better?
Sorry.
If my sand contain high silt content or clay content, which should perform better?
This one is a
You need to phase out naphthalene in your plant. You need to phase out naphthalene in your plant due to environmental issue. My project last time I phase out, I say no, not available. I don't allow because the formaldehyde is a byproduct. Then I just remove. No negotiation. Yes, the byproduct. China is phasing out actually because I got project there, but they still sell to you. I mean, export to you. In Europe they phase out, America they finally.
Ethylene still very active in island.
But I don't want to comment much, but the site, the byproduct is different. I can buy a low range PCE rather than no, I don't want to use naphthalene. I just need to buy low range PCE to substitute it. Pricing you need to know because ESG is coming. You need to consider all these things.
Naturally, we all face out long time. 10 years.
Your company is different, the ready mix is different story.
Yeah.
Long time.
And.
Naturally, it's 12 years ago. 12 years ago.
It's so easy to manage. So that's why long time ago you guys just admitted. At least today you have experience. Because if not, you always have been working for 10 years then other chance. But right now you can make a different type of performance. Okay, I have one more, which is the what we call set accelerators. So what happened is once you add in this, your set accelerators. This one is brand, but I shouldn't put it, but it's easier for me. So once you put it in, the concrete will set immediately to a certain position. But I think if let's say you want to have a better feeling, you add in more super, make it better. That only I think you guys can see it. But make sure there's one more thing just now not highlight. Your BNS and PC, you never mix it together.
I want to show them the example now.
Oh, you want to show it?
Okay, just mix like this.
Ini macam lepas kapal feeding
Okay.
sekolah.
Then my PCE, where's my PCE?
Kapal punya.
Someone help me to simply dose some PCE inside.
Yes.
Simply drop is okay. Not enough. Masih tak enough. Okay. Ini campur tak tahu punya ya.
You guys use it. I don't know what this one is just for them.
Biasa tukar nama. Dia tak ambil lah. Kalau you nak dia pergi kilang dia. Nah, ada lagi.
Okay, now I make it like super fluid. Take another one, not PCE. You cannot use PCE, you spoil the whole.
What's the difference?
The what? No, I mean the pipette.
New pipette lah, new one lah.
Now it's very fluid.
You have limited.
Why cannot using the C?
They are all friends.
Naphthalene.
You want to press them out or you think they. Now the workability start to become very start to sticky. Or you overdose, then you off the PCE. I have a project. The plant failed to mix the concrete because they didn't clean the pipeline. I mean the dispenser.
Oh,
It's actually getting more difficult, but I want to accelerate.
they solidify already.
Tambah kasih dia Overdose, bro. Cannot tell you. Okay, suppose lah, technically actual side mix it shouldn't be like this. It becomes suddenly your slump loss. This one overdose already. I think water is more than the pest. Okay, suppose directly your slump will loss. So PCE cannot mix with and like DNS. We just put a bit. We wait for a while, but normally.
Just increase the hydration process typically, or is only the
Water reductions. This one is BNS. Water reductions.
additional one? Make it more
Not
specific.
like this.
Because it doesn't.
Make another day.
You see, of course, possible you don't do this. You don't this. Be a singlet.
India they do that.
Yeah. So yeah, but at least one thing they do curing. Yeah, even though they are all wearing t-shirt to do curings. Yeah. Okay, so next will be the materials. We're going to materials. Okay, just now you mentioned cement. How many types of cements we have? Can be used? How many types? Under the S4, S5. How many types total? Just now I heard answer. Oh, I feel okay lah.
Finally finding.
There's 7 types of cements that we can use. Yeah, under the galvanized autos. Yeah. So, okay, any reason why OPC is called OPC? Ordinary Portland cement. For some they call ordinary cement. But why ordinary Portland cement is used?
Origin from Portland, because it's from Portland.
Yes, it's from Portland. Okay, so I think this ordinary Portland cement is actually from Portland, and then they have actually this ordinary Portland cement is actually a patented material. Long time ago. Long time ago, this material is patented. You can't use Portland cement for anyone, but right now it's open. But right now, I think it's become so into us, we still call OPC, ordinary Portland cement. But right, you're not Portland, right? Malaysia is not Portland. Why we use Portland? Ordinary Malaysia cement. But everyone is too used to ordinary Portland cement. So until right now, we are still using ordinary Portland cement. So second things, we'll go through on the supplementary cement aggregates and mixtures. I will keep it for next section. And waters, yeah. Okay. So, yeah. So, what's the function of cement? Anyone? Yes. So one of the functions of cement is to bind all your materials in your mix. Yeah, to glue up.
Super glue.
Yeah.
Certain country they call it binder.
Yeah. So I think a lot of times, sometimes you also mention what's the binder ratio, or instead of water cement, what's the binder ratio? It means it depends how you define it, but cement is also part of the bind. We require cement to bind the materials. So without cement, you put in pasir, can you bind? No, you can't bind. You can't bind. Yeah. So you need cement not only for strength but also to bind the materials. So second question is okay. One more question. How many tons of cement worldwide we produce every year? Every year, annual production for cement. Wow. You can Google lah. Google.
ChatGPT.
2 more seconds. Anyone? Ada. Google pun tak mau. Okay. Now, by generally, I think cement production annually, we produce 4.1 to 4.3 billion tons of cement. And then cement become, it also generate generally like 1 ton of CO2 per every ton of cement that you produce. So you can imagine how many tons of CO2 that we produce. But of course, you can challenge me right now with the new facilities, we can reduce by maybe 20%. But it's also a lot. It's also billion tons of CO2 that we generate. In construction, to give you a number, construction itself, we contribute 20% of CO2 worldwide. So that's the reason why a lot of times we want to try to make the optimize the mix, not only for money, but also for environment. Yeah. So, like what I mentioned just now, like what the gentleman mentioned, actually, the binders actually buying out both all the materials together. Yeah. So this is a few key components in cement. The grade is clinker. You add in gypsum, becomes cement. So okay. So this is the process of the cement productions. So can anyone answer me? Okay, actually, the production requires limestone. So where does the limestone origin from? Anyone can answer? Huh? No, you. Where does it? Simpang. Okay, you get one answer. Where does it origin from? What is actually limestone is? Limestone is? It's actually natural is actually from it's actually from seashell, from skeletons. So it's actually we are using materials from millions or billions years ago. Actually, from that seashell, it actually transformed to limestone. Yeah. So every layer of if let's say you go to one of the limestone, you have limestone, you have certain clay on top. Yeah. So you're right. Pernah pergi? So that's the reason from seashell. So there's one process I will just roughly go through. So once they excavate the limestone, they have to go.
Ada cabin.
Yeah, let me save my. How to save some money in concretes. Okay. Oh, right. Show me a hand if let's say because of Philip you have done it. All the rest I will assume you guys are coming for right? You know, right? So I think first of all I'm Alex, representing ACI Malaysia. So I've been in this industry for more than 10 years, specialized in concrete and mixtures. Yeah. So today we have actually done a couple of projects like TRX, the biggest hall in Malaysia. Yeah, 36 hours for almost 20,000 meters. So today we will be talking about these concrete technologies and site quality controls. Yeah. So this is some of my profile. I've been right now as working with a company like SICA and BCC for 10 years, more than 10 years, certified professional technologies, GFSA leaders, ACI of course, and also NTN. Yeah. So I think before we go into programs, this is the layout. So later you have the breaks after the sections. So after the second sections, you have our lunch around 12 to 1. So I think later on we'll continue until 3:30. We have tea breaks and end with hopefully around 5, right? Okay, so first questions. Anyone agree? This one is the cement floor. Show me a hand. Cement floor. So this is for sharing. In fact, concrete. The primary is concrete floor. Concrete floor. It's a concrete floor. So I think a lot of times, especially not only us, if let's say we are not in this industry, we actually misconcept what is concrete and what is cement. So concrete is actually the finished product. And then cement is just one of part of the ingredients of concrete. Yeah? So I think a lot of times, not only us, like videos, you'll say, oh, it's a cement truck, cement floor, cement wall. Yeah, so which is not really, in the terms wise, it's not right. Yeah. So I think first of all we need to know what's the difference. Okay, so which lead to my second question. So what is concrete? Anyone can guess? So today I want to be a little bit more interactive, so we prepare some gift. So whoever interact, answer, get some gift. Whether right or wrong, get some gift. So what is concrete? Anyone can answer? So anyone can answer. There's no right and wrong answer. Yes, correct. So okay. So we are done. We are done for today. You learn what is concrete. So concrete is just basically traditional just mixture of aggregates, primarily your cement. Cement is also called the binder. Binder for all your mixes. Water. That's all. That's all. On a modern concrete, we add admixtures. They're part of the composition of the concrete. So admixtures, there's two types. So can anyone give me answer? What type of admixtures do you have? Yes, that one is one category. Why I mean, okay, I have to rephrase myself. How many categories of admixtures that we have in the market? That one is called chemical admixtures. The other one? The other one is out of the cement replacement. We call it SCM. Yes, correct. We also call mineral admixtures. Yeah. So it's also part of the part of type of admixtures, which is used in modern concrete. So I think a lot right now. I believe you guys are also using it. I believe strongly. I believe you definitely will use admixtures for your pile. Grade 80, I think use conventional. It's nearly impossible because old-train concrete max maybe you can do grade 40s. Yeah, anything more than 40s you need supplementaries or these admixtures to boost up the strength. Yeah.
Just now you mentioned the two minerite and
chemical admixtures. Chemical admixtures, which is your super plus. Basically, it's your water reducer for your case. Yeah. So there's actually two types. Yeah, admixtures. So a lot of time people, okay, SCM is just SCM, but in fact it's also part of admixtures, but it's categorized differently. Yeah. So white space. Correct. So I think a lot of times we need to understand the terminologies before we even go into in what is concrete. So I think once the first thing we need to know what is space is you add cement, water, is space. So when people tell, oh, I need I'm doing a paste. So white space is just mixture of cement and then water. And also right now we have to add admixtures. So second, what is mortar? Yes. Right. Cement, water, and sand. Sand, we call it as fine paste. So when you use it, why we need to use that? So why mortar? Why we want to use aggregate? Because cements, everyone know, right? Cements is the main contributor for your track. So why? Any reason why you want to use cement or aggregates? Filler one thing? Yeah, correct. Yeah, I think so ultimately, one of the main reasons, other than you improve your durability, your shrinkage, your thermal, whatever. So the main reason why we use aggregates is to save cost. Then Philip will cut cement, cut cement, add more aggregates. It's not saying that it's wrong, but I think right now we talk about when everything will break. We talk about carbon footprints. So I think one of the criteria that we want to do is to make it optimized. The mix has to be very optimized. Not saying that over design or otherwise, you have to make it optimized mix for your concrete. So one of the main reasons why we use aggregates ultimately is to save cost. Yeah. So next is the cost of your concrete. Once you add in the rest of the balance, which is the cost aggregate, it's for concrete. Yeah. Concrete, yeah. So on a fully compacted concrete, yeah, this one. So on water cement ratio, so higher water cement ratio, higher strength or lower strength? Okay, basically, okay, you pass. Phillips. Everyone pass. Right? Alright, so I think basically the first fundamental we need to know on concrete is this graph. This one is the first thing when we learn about concrete technology. We need to keep in mind that the relationship of concrete strength and water cement ratio. This is the first part. Yeah, so the lower the water C, the higher the strength. Yeah, the higher the water C, the lower the strength. So I think there's one research that we have done. Actually, you only need 0.2 water C in a concrete to be fully high meters for cement to become high meters. So I think my next question comes to you guys is why we need more waters in a concrete mix? That's right, workability. Because other than whatever that we add on in a concrete mix for water is purely for workability. So later we will do a little bit of demo. You guys can feel. Yeah. So in a water C of 0.2, basically I would say, if let's say you have tried, basically you can't do anything in the concrete. It's lump. It's like you can't move it. So anything you put in is just purely for workabilities or your consistency. I mean, you want to get a certain amount of video workabilities that you require. Yeah. So I think right now that's why we need to just cut down your waters. Yeah. But anyhow, that one we'll talk about it later. So okay. So second, when we talk about strength, so how do we classify strength? Right now you're using, I believe, GAT, right? Minimum or G hundreds, yeah, 100 PS, right? So my next question for you is what is C? C660. Cannot be you always answer, like give people a chance. I can't believe you. But it's right. So I think this is one of the other fundamental terms that you need to know when we talk about this classification of strength. C/60. The first one is cylinder strength. /60 is cubical strength. So why we use cube instead of cylinders in Malaysia? Because I think a lot of research also mentioned that cylinder is more consistent strength. You give a true compressive value. But why? Any reason? Any reason?
Easier to form.
Easy. You get the right answer. Because I think the main reason why, I think it's not only Malaysia, around the world, people uses a lot of the cube. Because one of the prevalent reasons is easy to be cube. Instead of like, you have to do cylinders, you have to do a lot of maintenance, then it's not easy to do. But in fact, cylinders, a lot of research also mentioned that give a little bit, more consistent strength. Yeah. But that's the reason. Yeah. It's easy. Everyone wants cube. Easy. Everyone know how to do.
Maybe the material we are using.
Yeah, material also yes. Yeah, material. Yeah, but ultimately it's easy for the why they use this because it's easy. It's easy to manage. So this one is the classification. So what's the ratio, right? Give me a ratio. Cubical versus a cube strength versus a cylinder strength. What's the ratio? Anyone? Generally, cylinder versus cube. I can't give you. Sorry. Later I'll give it to you, but let the rest of us. So generally it's 0.8 to 0.85. Yeah, 0.8 lah, yeah, I would say. Versus your cube strength. So generally cylinder will slightly lower, but it actually reflects the true compressive value. So okay, the second question. Everyone know cement, specifically your cement is high grades, yeah, your form strength. So what's the material called? The strengths, the crystal.
Calcium
Give people a chance, I'll make sure answer. Cannot be always answer. Give people. So it's called CSH. It's a calcium silicate hydrates. It's actually a gel. It actually, over a long period of time, you actually form a gel. This gel is called calcium silicate hydrates. So this is the main components that give strength of concrete. And then one of the main components that a lot of people ignore is water. Because without water, the cement can't hydrate. So I think a lot of times people ignore use, use the clean waters. Yeah, because I think a lot of times, if let's say you use a recycled water or recycle, non-usable water, it might affect, right? Because one of the main components that you need is also the water. Yeah, so I think this is one of the things that a lot of people also ignore. So I think that's one thing that always have to be in mind. Because sometimes you can be using under control, but you have to check lah. Not saying you can't, but you have to check. The compatibility of your water. So I think over time, everyone knows these cement react with water, this crystal, CHH gel, you start to form over time. So this is one of the features that demonstrate the crystal formations over time. Yeah. So this one is 3 hours. When 3 hours, the concrete potability starts to reduce that. Or you stop. That means your concrete might not be workable. Because it's not because of your concrete is not firm, purely because the hydration process rate is different. Yeah. So I think over time, the crystal formation will be more. And until the concrete is fully integrated, over time. Okay, so this is just only guidelines on your concrete strength. So generally, on 3 days, you should be getting about 50% of your concrete targeted strength. 7 days, 75%, 30 day, 100%. But I think in your case, you want to achieve your strength. Maybe it's not only in 1 day, maybe in 12 hours.
Probably our process is a bit different.
Yeah, so but this one is just a general guideline on general concretes. I think for your site, you might be even more, because you're on the modern concretes. We talk about the normal concrete technologies. This is generally the guidelines for us. So on precast, of course, you're looking about 12 hours, or even some 6 hours, 8 hours. So the concept of the process might be a little bit different.
The curve might be maybe more,
steep. Steep. So I think also another thing is low is concrete, you always can interact. Over 28 days, concrete will still interact because concrete inside your particles, your single particle, keep on hydrating. With waters, with free waters. So over times, even though you're still getting strength. Especially right now, you use SCM or mineral pictures. So the strength gain is beyond the 8 days. You can start increasing. But of course, most likely, for 7 days or 3 days, you will regain. Alright, so that's two. When we talk about concretes, there's 2 parameters that we have to measure. One is on fresh concrete, the other one is hardened concrete. So on fresh concrete, anyone can give me an idea what do you guys measure? Which is So why do we measure? Other than that, what do you measure?
Temperature.
Yes, right, temperature. Temperature, yes. Why? Okay, before your step, why you measure slump? Workabilities. So you need to target certain. Why workabilities? Any reason?
Range of the sum for a school.
Okay. Ultimately, for workabilities, when we measure workabilities or consistency, we are only measuring one part of the concrete. So which is also lead to a reason why we only measure workability, because easily to measure slump, you need a flat surface. Just pull the con, you get workabilities. So everyone in the world can do. Instead of like you have to do with funnel or with the viscosity. People not saying they don't do, but it's actually they measure this as a benchmark. And the workability also measure how ease of the concrete placement. So the second thing, temperature. So why temperature is important?
Setting time.
Setting time is one. Second thing. The This one who answers that? Working time is also one, but it's not the main one.
This one also.
Not really on consistency. So anymore? Hydration. Setting time is one, the main one. Hydration. So I think the temperatures of concrete, fresh concrete, sometimes we can actually estimate the setting times or even hydration, what is already started. So these temperatures, most of the time, is important when you do mass concrete. That means you're doing a big pour, you have to control the peak temperatures. In fact, the initial temperature also lead to peak temperatures. So you have to control. So how do you control temperatures? If let's say you want to control the peak temperatures, chiller. Chiller is what? Chiller on chill water. Okay, chill water. Any more answer? What? You got any?
I got
Nice one. It's hard. Any more?
Anything retarded?
Huh?
Retarded?
Retarder, yes. Yes, but it's not really that much temperature. It helps, but it's not the main one. Chiller, any? Any more? So how to control temperature initially?
Control the delivery of cement.
Cement, one. You also answered correctly. Any more?
More material.
The main component. What's the main component in a concrete?
Aggregate.
Yes, aggregate. So the main thing to control your concrete is to control your temperature of aggregates. Yeah. So once you control your aggregate temperatures, instead of like, for example, if let's say you really want to control like below 30 or 35, you can actually chill aggregates. For example, yeah. So first, ultimately, the biggest portion is not your water, it's your aggregate. So if you have, let's say your aggregates, for example, already at 40 degrees, yeah. What do you expect on your fresh concrete? Must be high. Yeah. So I think one thing's, yeah, you're right. The others, chiller or ice, you can actually, but the main one is aggregate. This is what people always ignore. Aggregates are cheap, I don't think I ignore, but in fact it's the most important to control your
Especially just those factories plant without bunker system. We have to use a sprinkler to reduce the temperature.
So it also impact like what you mentioned, setting time over 30 degrees.
Yeah.
So that's the reason why you need to control your aggregates.
Yeah, especially in the afternoon. So the heat
Start to
absorbed by the bacteria. So mostly afternoon, then you'll see more. Concrete fast slump loss for this issue.
Yeah. So that's the main reason. So a lot of times we recommend you need to be shaded, but I know some of the reasons it can't be. But you need to know the aggregate also play a main role in your concrete fresh temperatures. Yeah. Okay, come to next. Hardened concrete. So what do we measure in hardened concrete?
Transit strength.
Yes. So any other things that you guys measure other than strength? Strength.
The weight is
Weight. Yeah, weight. Yeah. So generally there's any more? Strength and weight.
Dimension.
Yes, correct. So generally we measure the main one because when we talk about hardened concrete, we try. Because this also gives just now, and this is what the consultant want to see. What's the strength? What's the strength? But I think a lot of times on hardened concrete we can actually measure more than only strengths. We can measure durabilities, capacity, value, and also the like this waterproof concrete. Sometimes they measure the absorption value. So there's a lot of things that we can actually measure other than only strengths. So there's a lot of parameters that we actually can measure other than strength. Of course, strength is the most important, but there's a lot of criteria for testing that we can do on the concrete, hardened concrete. Yeah. So on fresh concrete, like this now we have actually covered the main one, workabilities that you guys always do. But guys want, you also can test segregation and also readings of your concretes, or your fresh concretes. Yeah. So vulnerabilities, I think maybe you guys maybe relate a bit, depends on your casting methods. If let's say you talk about, like for example, you want to pump concrete vertically 30 meters or 50 meters or 100 meters, this become a very crucial parameters that you have to measure. Yeah. So next will be workability retentions. So I think sometimes what I mean is anyone can answer retention. Workability retention. I think maybe not relate much to you guys, but it's also important. Yeah, for projects. So workability retention, that is you are allowing your concrete to be workable. That means your slump can be maintained for certain period of times. Yeah.
Slower slump loss.
Slower slump loss. For example, for certain case, if let's say you are doing piles, for example, you are ordering materials from ready mix. So the journey to travel to a plant maybe for example is 1.5 hours. So you are expecting the batching plant, once they batch, without adding any waters, yeah, they maintain the same stability at the site. Yeah, that's how I mean the Islamic religion. Yeah. So set times you guys mentioned, and also temperature. Yeah. So why fresh concrete is important to measure all this? Yeah. So I think one of the main reasons why we always need to measure fresh concrete is because it gives you an indicators whether your concrete is usable or not. The second, it actually gives us an indicator what will happen next. For example, if you batch out your concrete already started 8 or 7 days, you yourself, let's say you want to use, you already know what will happen next, right? So this one is the indicators. Instead of like, okay, I use a mix, for example, a boss give you, for example, a mix design, every day you just click. Of course, we always expect the same performance or same concrete will come up, but in fact, we are dealing with natural resources. Everything is natural. Even the grinding, your cement, come from nature. Your sand, don't talk about sand. Sand even, the variety is even more, worse. So it's not always when you clay, your concrete, fresh concrete might not be the same. So that's one of the key parameters why we need to measure fresh concrete. So don't never be too overconfident. Today I batch confirm. Tomorrow confirm then might not be the same. The next hour might not be the same when you do dry mix. If let's say you experience a lot of dry mix, you know this round pagi buat, petang saya buat sama mix apa tak dapat. Yeah, because we are dealing a lot of these variabilities in your concrete. So that's why fresh concrete is the first indicator benchmark for you guys. Yeah. So bleak concrete, you guys accept bleak concrete? No, 0. Because you guys don't accept.
Yeah.
So but for certain application, they like a little bit of space, especially flooring by flooring. Yeah. But of course for application definitely no, 100% no. Yeah. This one, do you accept? Anyone accept? I give you 2 gifts. Let's say
No, a big no. A big and no.
Yeah. So this, so I think when you see this, definitely we do not want to accept. It's already segregated. You can see the has been actually separated from the aggregate. Yeah. So we do not want to accept this kind of concrete. Yeah. Of course, a lot of times, I can do it just fine. Up to your risk, but risk appetite. But when you see this, I think it's big. Yeah, big.
There's a style in the ready mix, then bring back the put cement. Is it okay? Just to ask you.
Anyone want to answer? Philip, you want to answer? You answer.
I think it's more on the concrete itself, because but the concrete is still workable, you still can mix it. But of course, the traveling time from the site back to the plant might take maybe 1 hour or half an hour. So by the time that you mix another cement and chemical, rework it, then and send back to the site maybe probably after 2 hours, which is more than 2 hours means the concrete already like start hardening, so might not be practical. Yeah.
Okay, so you ask me personally, you want to have cement, you can use it for, depends on concrete, like first of all, when you receive back, depends on the condition, but generally, I will do it.
Yeah, it's not encouraged to do it.
Yeah, unless you want to just do like a normal, your gardening pavements, by all means, you can do it. Yeah, you just do a normal place, it's fine. As long the strength is not a main concern for you, you can actually use the concrete up to the resentment time. Yeah, but for concrete, reinforced concrete at least.
For the concrete mix design itself, there is some problem because it's segregated. So by right, it shouldn't be. I mean, they work.
So you maybe come from say the mix design, might come from maybe the patching, raw materials, might be a lot of issues it might cause. So that's why a lot of times you have to measure fresh concrete. It's not necessary one joke to one, so you have to measure. You have to measure fresh concrete. So you give your indicators. If without measuring, you always feel okay, confirm. This one is what I will get. I assume I will get, but not necessary. So this one you accept? Accept. Right, lucky you guys. I thought you guys. No. Okay, when in big projects, one of the main criteria is also we talk about pumpability. So pumpability also reflects the rheology of concrete. That means how easy your concrete can move with certain resistance. Without resistance, So this might be important when you feel it pumping. So if let's say you are pumping, you might also want to consider checking the pumpability of the concrete.
How do you check the pumpability?
Pumpability, there's actually a test to check the okay, there's few methods. You can use the basic conventional, maybe you can use start with
Funnel.
funnel. That's one is indicative, but if let's say you really want to check the pumpability, there's actually a standard to check how fast it actually goes. The piping. So they actually working on use the actual concrete to pump it. They'll check what's the outcome. That means before and after, what's the outcome. That's the right way on checking. Because I think a lot of big projects, they will use this method.
I see. Because why I ask this question is because you know we have few plant that needs pumping. So of course we have experienced all this pumping starts, all these things, which is actually also boils down to the what sort of resources are being used. Sometimes the sand can be a bit coarse, that also affect the pumpability. And also we saw that different emissions have different effects as well on the pumpability.
There's a lot, yes, you're right. So I think this also depends on, I say, which the binder, how high is the binder. But of course, you don't want to use a lot of binders. Even though you know you have a lot of binders, you it's easy to pump, but try to optimize it. The second is cost. We don't want to do is add water. Water also makes the concrete easier pumper, but we don't want to. So I think there's a certain technologies in concrete mixtures. It actually help to improve the rheologies. But of course, come with mixed design comes with the second is because mixtures there's a lot of different types of concretes. So we actually which I will
we hope your refined MBCC here admission can help.
Hopefully, and other than so that's why I hope maybe Dana can answer also. So on other concrete, just now we've actually covered the main one, which is strength. So just now you also mentioned. So the second is density, which is how the weight of the concrete. So if let's say you know the concrete density is high, it's good or low. Density high, good or low, it's good.
Not too low, not too high.
that's answer is correct. So density no generally